Hello everyone. Today in this video we will discuss some topics like centroid and center of gravity. So first of all, what is mean by center of gravity? Suppose if we consider any rigid body, that rigid body is made up of a large number of the particles and each particle is attracted towards the earth. So the gravitational forces of all that particles in a random rigid body will act in the parallel directions only. So the resultant of all these parallel forces is nothing but a gravitational force or weight of that particular body and acts through some specific point. So that point through which the whole weight acts or weight is assumed to be concentrated, that point is nothing but a center of gravity, or in one word we can say that whole weight acting point is nothing but a center of gravity and it is denoted by Cg. Now what is meant by centroid means, for some plane figures like square, rectangle, triangle, for such type of the plane figures you will have only areas, you will not have any masses for them. So the whole area acting point for that particular body is nothing but a centroid and it is denoted by G. So for the plane figures, center of gravity is replaced by centroid. Once again, whole weight acting point is nothing but a center of gravity. Whole area acting point is nothing but a centroid. Now center of gravity or centroid, both are nothing but a coordinate points only. So we should find the position of that center of gravity or centroid points with respect to the x-axis or with respect to the y-axis. So to locate the position of that center of gravity and centroid points, we need to take the help of the principle of the moments. Now once again, what is meant by principle of the moments from the first unit? Resultant moment is equal to sum of the individual moments. Now by using that principle of the moments topic, for any rigid body we can calculate the position of the center of gravity or centroid with respect to the x-axis and with respect to the y-axis. Now let us consider a random body here, random rigid body. For this rigid body I am considering only two particles. Here first particle is there, here second particle is there. So for these two particles, W1 and W2 are nothing but the gravitational forces of these two particles. So the resultant of these two particles is nothing but a total resultant force. So the total resultant force is nothing but gravitational force or weight of this complete rigid body. So that total weight, total gravitational force is acting at this point. So this point is nothing but our center of gravity point. So as that is a point, as that is a coordinate point, it will have a distance, x distance and y distance with respect to the x-axis and with respect to the x-axis. So we should find that position in terms of the distances about the x-axis and about the y-axis. So to calculate the position of that point, we need to take the help of the principle of the moments. Now first of all we will take the moments about y-axis. So calculate all the individual moments and the resultant moment about the y-axis. We know the formula for the moment as force into perpendicular distance. So here x1 and x2 are the x distances for the W1 and W2, and y1 and y2 are the distances for this W1 and W2 forces with respect to the x-axis. So by using all these distances and by these forces, we can calculate the total resultant force and individual moments. So here first of all, resultant moment. So resultant force is nothing but W only. So W into x bar, force into perpendicular distance. So W into x bar about y-axis is nothing but resultant moment. That resultant moment is equal to individual moments. So W1 into x1 and W2 into x2. So summation of the individual moments. From this one, make subject x bar. So x bar is equal to W1 x1 plus W2 x2 by W. From this one you will get the x bar value, x bar distance of that center of gravity with respect to the y-axis. Now do the same procedure for the y bar. Y bar is nothing but y distance of that particular center of gravity point with respect to the x-axis. So take the moments about x-axis. So W into y bar is equal to W1 y1 plus W2 y2. Then you will get the y bar formula in this way. So we got the x bar distance and y bar distance by using the principle of the moments. So total center of gravity point is nothing but, as it is a coordinate point, it will have both coordinates, x bar and y bar. So you will get in terms of these formulas. Suppose for example, for solids, you will get the same formula but in terms of the volumes. Why? Because we know that W is equal to mass into gravity, and again mass is equal to density into volume. So from that substitution of the formulas for the weight and the mass, you will get the same formula in terms of the volumes. So in the problems generally, if you find any solid bodies, so for such type of the problems you can use this formula. So W is replaced with V. You will get the same formula but you will replace the W with V. V is nothing but volume. And now coming to the centroid formula, for plane figure, center of gravity is replaced with the centroid. G is nothing but centroid. So position of the centroid from the y-axis and the position of the centroid from the x-axis, you will get the same formulas but you will get the formula in terms of the areas. If you do the same procedure by using the principle of the moments for this diagram in terms of the areas, not in the weights. If you do the same procedure in terms of the areas, you will get these two formulas. Like x bar formula is this one and y bar formula is this one. Suppose for example, for lines, the same formula of the centroid is replaced with the L. A is replaced with L. So suppose for example, in the problems, if you find plane figures like rectangle, square, triangles, you can use this formula. If you find lines, you can use this formula. Or if you find any solid bodies, you can use the volume formula. According to the given data, according to the sections given in the problem, you can use any one of these x bar and y bar formulas to calculate the centroid and center of gravity. Now we will see some examples to calculate the center of gravity position. Some for symmetrical sections and some for unsymmetrical sections. Now the point is, what is meant by symmetrical section? Now everyone observe this diagram. Here this complete section is symmetrical about y-axis. That is nothing but if any section is split or cut with respect to any axis. Here y-axis is there. So this complete section is split or cut about y-axis. So it will have the mirror image about this y-axis. So this section is nothing but a symmetrical section. Or simply in one word we can say that if any section is having a mirror image about any axis, then that section will be symmetrical about that axis. Everyone observe this second diagram. Here it is not symmetrical about x-axis and it is not symmetrical about y-axis also. If we cut this section into two parts about x or y, it will not have any mirror images about any x-axis or y-axis. So this section is nothing but a unsymmetrical sections. And one more thing, for unsymmetrical sections problems, you need to calculate the x bar distance as well as y bar distance in the center of gravity calculation process. But for the symmetrical sections, if any section is symmetrical about the y-axis, then you will have only y distance only. So you need to calculate only y bar. X bar will be 0. Suppose if any section is symmetrical about the x-axis, then you will have only x bar distance and y bar value will be 0. Now we will see the procedure how to calculate the x bar and y bar and then to locate the position of the center of gravity. So this is our symmetrical section problem. So here here three sections are there and this section is completely of a plane figures. So for the plane figures you will have only areas. So when you have the plane figures and you need to calculate the areas, this will be the formula. Like centroid x bar y bar is equal to sigma ax by sigma a comma sigma ay by sigma a. So in the complete problem you need to calculate the areas and x distances and y distances. Now here how many sections are there? Three sections are there. So individual centroids of the individual sections, by combining all that individual sections centroid values, we will get the total centroid value. Now here for easy calculation purpose, you draw once again the original diagram. Once again you project the original diagram. Now consider this section as first section, next this section as second section, next this section as the third section. Next locate one point, that point is nothing but a centroid point of this section, first section. So locate the centroid points for the individual sections. Next, as it is symmetrical about the y-axis, you will have only y bar distance. So y distances with respect to the x-axis only. So project one x base. Next, for this x base, you project the y1 distance, y2 distance, y3 distance from the individual first section, second section, third section to the x base. So here from the centroid to the x base, y1 distance. From the centroid of the second section to the x base, y2 distance. From the centroid of the third section to the x base, y3. If you project this diagram once, then it will be easy for us to calculate. There will be no confusion in the procedure. So this diagram is compulsory. So now for this diagram, once again you write the individual dimensions also. Here for the first section, dimensions are given as 300 and 100. So 300, 100. For the second section, 50 and 300. So 50 and 300. For the third section, 150 and 50. So 150 and 50. In this diagram, locate the centroid points and locate the number wise sections and locate the x base and locate y1, y2, y3 individual distances of the individual sections up to the x base and write the dimensions once again for the individual sections. By doing this procedure, it will be easy for us to calculate the problem. Then as here three rectangular sections are there, and these are plain figures, you will get the area formula and x bar and y bar formula in this way. Like area for the rectangle is equal to b into d. B is nothing but base and d is nothing but depth. So x bar formula is b by 2 and y bar formula is d by 2. So according to this fixed formula, we need to calculate all the values. First of all, we will calculate the area values for the individual sections. So here A1 is nothing but area of the first section. So b into d. So 300 into 100. Next, area of the second section. B into D. 50 into 300. Next, area of the third section. B into D. 150 into 50. So these are the values for the areas of the individual sections. Next, y bar formula is nothing but d by 2. D is nothing but depth of that particular section. So y1 is from here to up to the base. So what is the formula? D by 2. Here depth value for the first section is 100. So exactly 100 by 2. So 100 by 2. Next, y2 is the distance from the centroid of the second section and up to the base. But formula will be applicable up to that individual section only. But we need to calculate up to the x base. So y2 will be, what is the formula for the rectangular section? Y bar formula d by 2. So here for the second section, depth value is 300. Depth value is 300. So 300 by 2 up to here. Next plus remaining 100 up to the base. Once again, formulas will be applicable up to the individual sections only. But we need to calculate up to the bases. Here base is x base. So formula is d by 2. So here depth is 300. So 300 by 2 up to the second section here and plus remaining 100 up to the x base. So 300 by 2 plus 100. Next y3. Y3 is nothing but from this point to up to the x base. So what is the y bar formula for the rectangular section? Again d by 2 only. Here for the third section depth value is 50. So 50 by 2 up to here plus remaining 300 plus remaining 100 up to the base. So 50 by 2 plus 300 plus 100. So these are the calculation part. From this one, as here three sections are there, you will get the formula in this way. A1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. From this calculation, you will get the y bar value. And as it is symmetrical about the y-axis, you will have only y bar distance and x bar is equal to 0. So G centroid x bar comma y bar is equal to 0 comma whatever the value you will get in the calculation, that is the value here y bar. Once again, formulas of x bar and y bar will be applicable up to that individual sections only, but we need to calculate the distances up to the base. So calculate the distances up to that sections by using the formulas, and add the remaining distances up to the bases. So this is the problem related to centroid of symmetrical section. Now we will see one unsymmetrical section problem. So for unsymmetrical sections, x bar value will be there and y bar value will be there. So once again project the same diagram as it is, and here see here it is a L section. It is a L section. Now you can do this problem in two ways, by taking the sections in the different manner. Like suppose for example, if you project one line here, you will get here one section and here one more section. Suppose for example, if you project one line here, then you will get this small section as the first section and here one big section as the second section. So you can do the same problem in two ways, like you can take one vertical line here or one horizontal line here. If you do in any method, you will get the same answer only. So I am taking the two sections in this way, like projecting a vertical line here. So then this will be called as the first section, then this will be called as the second section. Now for these two sections, locate the centroid points. Next, locate the individual dimensions for the individual sections. As this is the first section, what is the base value for the first section? 20. Next, what is the depth value for the first section? 100. So 100. Next, see the individual dimensions for the second section. So individual second section depth value is equal to 20. So here 20. Next, from here to here, that is the second section, not completely from here to here. So complete distance is given as 80. So 80 minus 20, remaining distance will be 60. So 60 is the dimension base value for the second section. So write the individual dimensions for the individual sections once again in this diagram. Next, as it is an unsymmetrical section, you will have x bar value and y bar value. So locate x base and y base. Now locate x1, y1, x1, y1, x2, y2 with respect to their x base and y base from the centroid points. So here y1 is the distance from the centroid to the x base. y2 is the distance from the centroid to the x base. Next, here x1 is the distance from the centroid to the y base, and x2 from the centroid point to the y base. Remember one thing, x1 and x2 to the y base, y1 and y2 to the x base, opposite bases, distances will be to their opposite bases only. X bar to the y axis, y bar to the x axis. Now as here this problem is completely related to the plane figures, and here two rectangular sections are there, you will get the area formula as again BD, and x bar as B by 2 and y bar as D by 2. Remember one thing, base is nothing but base, and depth is nothing but here height. Next, here what is the first section? Here this is the first section. So area formula is B into D. So for the first section, B base is nothing but 20 and depth is nothing but 100. So 20 into 100. So 20 into 100. Next, area of the second section, base is 60 and depth is 20. So 60 into 20. So 60 into 20. Next, x bar formula is B by 2. So x bar is the distance for the first section from the centroid to the y base. So what is the base value here for the first section? 20. So 20 by 2. So 20 by 2. Next, x2 for the second section centroid value to the y base. So what is the formula? B by 2 only. So what is the base value for the second section? 60. So 60 by 2 up to that section only. But we need to calculate up to the y base. So formula will be applicable up to that individual section, and we need to add the remaining distance up to the y base. So 60 by 2 plus 20. So 60 by 2 plus 20. Next, what is the y bar formula? D by 2. So for the first section, depth value is equal to 100. So 100 by 2. So 100 by 2. Next, again for the second section, depth value is equal to 20. So 20 by 2. So 20 by 2. So from these two formulas we can calculate the x bar and y bar. So centroid value for this unsymmetrical section is, you will get the x bar coordinate value and y bar coordinate value by using the calculation. Remember one thing, once again, formulas will be applicable up to that individual sections only, but you need to calculate the distances up to the base to calculate the total x bar and y bar. Once again, in the symmetrical section, see here y3 value, y3 is nothing but from this point up to the x base, but formula will be applicable up to that section only. So d by 2, so 50 by 2 up to here. Next plus remaining 300, next remaining 100 up to the x base. So in the same way here x bar, here x2 value, here b by 2 value is the formula for the x bar for the second section. X bar for the second section, base value is equal to 60 only. So 60 by 2 up to here plus remaining 20 up to the y base. So formulas will be applicable, x bar and y bar formulas for any section will be applicable up to that individual sections only. You need to calculate the distances up to the x base and y base to calculate the total value. Once again, if you draw these diagrams based on the original diagram, it will be easy for you to locate these points, to locate these distances. From the main diagram also you can do the procedure, but once if you draw this diagram and once if you locate all these points and locate all the individual section dimensions and individual x bar, x1, y1, y1, y2, if you locate all these values in that particular diagram, it will be easy for us to calculate all these things. So you can draw this diagram in the external exam also. So these are the example problems for symmetrical sections and unsymmetrical sections.